In this video, we're solving problem 3.3.21 from Essentials of Statistics, 6th edition by Mario Triola. We're asked to use the following cell phone airport data speeds in megabits per second from a particular network, and then we're asked to find the 70th percentile. So basically, and this is just approximate, basically, we want that number that separates the bottom 70% from the top 30% in our data set. So in order to do that, I'm going to use Excel. So we'll open this data in Excel. Oops, I accidentally saved the file last time. I wanted to open it. There we go, there it is. Now it looks like all of this has already been sorted, but if it wasn't sorted, we could highlight the column and then click sort from smallest to largest. There you go. And we're looking for the 70th data value on this list. So first we're going to sort as we've already done, and then we would calculate L. I'll show you my piece of paper so you can see what I'm doing. So after you sort, you want to calculate L. And L is basically a marker. We're trying to find that data value that separates the bottom 70% from the top 30%. In order to find that, we need to take the number of values that we have, and I believe that was 50, if I was looking at that correctly, yes, the number of values that we have, and we need to multiply by the percentile that we're looking for. So if we're looking for the 70th percentile, we're basically taking 70 over 100, which is 0.7, and we're multiplying it by the number of values that we have. So we've got k equals 70, because that's the percentile we're looking for. And so we're taking 0.7, which indicates 70%, and we're multiplying that by the number of values that we have. So you'd say to yourself, well, what's 70% of 50? That's 35. Now from here, we handle this differently if L is a whole number than if it's not a whole number. If it's not a whole number, if the answer to that question is no, then we round up to the next integer value. And of course, it's going to be a positive number. So I guess we could say it's the next natural number. Then that value on the list represents your 70th percentile. Now this is not the case for us, but I want you to know how to do this just in case you see a number that is not a whole number here. So if this was 35.2, let's say, we would say, no, L is not a whole number because it's 35.2. Then we'd round up to 36. And then we go to our list of data, and we look for this 36th number on the list. The 36th number on the list in that case would represent that kth percentile, or the 70th percentile in our case. Now, if this is a whole number, then you are actually not looking for that 35th value on the list. You're going to look for the 35th value on the list and the 36th value of the list. And you want to compute the mean of the Lth value and the Lth plus 1 value. I know it sounds funny on your list. So in our case, L is 35. So we're computing the mean of the 35th value on the list and the 36th value on the list, and that's going to represent the 70th percentile. So let's look at our data again. So I'm looking for the 35th and 36th entry. I've got 6.4 and 7.4. So I want to add those together and then divide by 2. You guys think of the number that's halfway in between 7.4 and 6.4? I hope you can. It's 6.9. Okay, so 6.9 is the 70th percentile. Actually, I do want to go back to sharing again. I just don't want to share my Excel spreadsheet. Now I want to share the homework assignment itself. Okay, so we're here. And the 70th percentile was 6.9. And my lab statistics likes it, so we know we did a good job.